Hello and welcome to our learning series on Agile transformation, a learning series brought to you by Sternbridge Technology Consulting. I'm the host, Kenny Gibbons, and I'll be taking you through this learning course. Welcome back to the Agile Transformation Learning Series. Today, we are on episode 7. In this session, we are moving from team-level Agile into one of the hardest parts of Agile transformation, scaling Agile across a large organization. We will cover the common challenges using practical examples, and we'll introduce a scaling framework that is used widely in the life sciences industry. Before we go further into today's topic, it is helpful to briefly connect this episode to the prior sessions in the series. The previous episode covered advanced Scrum topics and focused on 3 important areas that become highly relevant in life sciences implementations. We discussed extended Scrum roles, including roles that are especially important in regulated environments such as compliance, along with roles like business analysis, user experience, and DevOps. Second, we covered backlog grooming and backlog management, including how teams should define, prioritize, and prepare work so that delivery stays structured and efficient. Third, we covered sprint planning and capacity management, with an emphasis on building sprint plans that reflect real team availability rather than optimistic assumptions. That foundation matters because scaling Agile across an organization depends on teams understanding how to operate Scrum effectively at the team level. If you would like a deeper review of the Scrum process and those more advanced team level topics, go back and watch episodes 5 and 6 before continuing with this session. To set the stage for today's discussion, consider what a modern digital organization in life sciences may actually look like. A global pharmaceutical or biotech company may have anywhere from 150 to more than 1,000 people contributing to digital delivery across manufacturing, quality, supply chain, data platforms, cloud engineering, cybersecurity, enterprise applications, analytics, and AI. These teams often support a broad enterprise landscape. All of those groups may ultimately be trying to drive toward a common strategy. That strategy may include plant modernization, better manufacturing visibility, AI-enabled operations, or a more connected digital backbone across the enterprise. That is where the scaling challenge begins. On today's episode, we will set the stage for scaling challenges that occur and introduce the framework for overcoming the challenges. We are going to look at 4 topic areas to cover this concept. First, why scaling creates a different delivery problem. Second, the limits of team-level Agile. Third, the enterprise coordination issues that begin to dominate once organizations grow. And fourth, why structured scaling approaches such as SAFe emerged in response. Let's begin with the first idea. At the team level, Agile methods are highly effective. A Scrum team can establish clear priorities, work in short feedback cycles, and adjust quickly when needs change. Communication is direct. Planning is visible. Stakeholder access is often manageable. The team has enough local autonomy to solve problems and move forward. At enterprise scale, those conditions weaken quickly. One team can no longer see or resolve the entire system around it. Product roadmaps, plant priorities, enterprise architecture, data platform decisions, validation activities, and budget cycles all begin to influence delivery. Scaling is about redesigning how the organization coordinates work. Scaling is not about doing more agile ceremonies. This distinction is important. If a company has one team enhancing a manufacturing dashboard, basic Scrum may be enough. If that same company is modernizing manufacturing execution, integrating shop floor data, building a cloud data platform, standing up AI models for predictive operations, and rolling out standard quality workflows across multiple plants, the coordination model has to change. In that environment, success depends on how well the organization connects strategy, platforms, teams, and decisions. This is where many large enterprises struggle. They expand Agile teams without redesigning the coordination system around them. They expect local Agile success to scale naturally. In practice, new friction appears faster than new value. That brings us to the limits of team-level Agile. Team-level Agile is genuinely valuable. It helps small teams organize work, improve transparency, create ownership, and learn quickly through iteration. Scrum and Kanban are still highly useful in enterprise settings. The problem is not that they stop working. The problem is that their scope has natural boundaries. Scrum helps a team run a sprint. Scrum does not automatically align 20 teams across one manufacturing transformation. Kanban helps manage workflow. Kanban does not automatically resolve shared infrastructure bottlenecks, portfolio contention, or governance delays. Local agility improves execution discipline, but it does not guarantee enterprise alignment. Consider a life sciences example. A manufacturing digital program may involve one team working on plant connectivity, another team building cloud data ingestion pipelines, another modernizing deviation workflows, another enabling AI based analytics, and another handling planning integrations. Each team may use Agile effectively, demonstrate progress every 2 weeks. Yet the broader initiative can still fall behind because the teams are dependent on shared master data, common architecture decisions, validation sequencing, and release windows tied to plant operations. No single team can solve those issues on its own. This is why team level Agile has limits. It remains valuable, but it does not solve enterprise scale coordination by itself. As more teams contribute to the same business outcome, cross team coordination becomes the dominant issue. First, many teams need a common alignment mechanism. Second, visibility into progress fades as the system grows. Third, the number of dependencies expands quickly across technical, operational, and organizational boundaries. This is easy to see in manufacturing and enterprise platforms. A plant analytics team may finish a sprint, but the cloud platform team has not yet provisioned the environment they need for production deployment. A quality workflow team may be ready for testing, but integration with SAP or a shared release calendar delays progress. An AI operations team may have a strong use case for predictive maintenance, but the historian, asset hierarchy, and equipment master data remain inconsistent across sites. These are all examples of work slowing down because coordination is weak, not because the teams are weak. That is a critical lesson for large enterprises. Friction often lives in the system, not in the people. When this happens, leaders sometimes respond by pushing teams harder. That rarely solves the issue. A delivery system with poor coordination does not become efficient because people work longer hours. It becomes efficient when alignment mechanisms improve. Governance and portfolio friction add another layer of complexity. As organizations scale, each leadership tier sees the system differently. A director managing one domain may focus on a single roadmap, such as manufacturing analytics or digital quality. A senior director may balance multiple programs at once, such as plant digitization, cloud data modernization, and enterprise AI enablement. A CIO or business technology leader may need to make trade-offs across cybersecurity, enterprise architecture, AI platform investment, data strategy, and regional delivery priorities. Each layer adds complexity to the delivery system. At the domain level, a leader may be frustrated because funding arrives in large annual cycles while the teams deliver iteratively. At the multi-program level, leaders may see competition for scarce resources such as cloud engineers, validation support, data architects, or plant subject matter experts. At the enterprise level, the challenge becomes broader. Annual planning, capital allocation, security standards, compliance obligations, and strategic platform decisions all interact with the day-to-day rhythms of Agile delivery. This is especially visible in life sciences, where digital priorities often span both corporate and site-level needs. A CIO may approve enterprise investment in a common cloud data platform. A manufacturing leader may need faster insight into OEE or yield loss. A data and AI team may want standardized pipelines and reusable models. All of those goals are valid, but without a common operating model, they create friction. That is why leadership alignment becomes part of Agile scaling. The next major source of complexity is dependencies. As life sciences organizations grow, dependencies multiply across several categories. The first category is technical dependency. In manufacturing, those technical dependencies often center on common digital infrastructure. The second category is decision dependency. Progress may rely on architecture boards, cybersecurity approvals, validation leads, site governance teams, or business sponsors. A team may finish development work but wait weeks for a key design or release decision. The third category is operational dependency. Shared services often control key parts of the delivery path. Examples include infrastructure teams, data platform teams, compliance functions, and testing support. If 5 programs are drawing on the same shared service group, the pace of delivery depends on more than sprint discipline. The fourth category is cross-functional dependency. External and adjacent groups often move on timelines that the team cannot directly control. Examples include vendors, implementation partners, software providers, plant operations leaders, and regulators. A manufacturing transformation team may be waiting on a system integrator, a validation package, or plant downtime windows before value can be released. When these dependency layers stack together, teams become reliant on parts of the organization far outside their direct control. Leaders need clarity. They want a better way to connect strategy to execution across many teams. They need a shared planning rhythm, clear visibility into dependencies and risk, and governance that supports flow rather than only creating more checkpoints. Teams need alignment. They want clearer priorities, earlier visibility into cross-team blockers, more predictable decisions from leadership and shared services, and fewer late changes that disrupt the sprint. This is an important point in organizational maturity. The problem is no longer whether Agile works. The problem is whether the enterprise has designed the right system around Agile teams. This is also why structured scaling approaches emerged. Most organizations move through a similar pattern. First, local Agile thrives. Teams adopt Scrum or Kanban and see immediate benefits. Feedback becomes faster, work becomes more visible, ownership improves, leaders become more confident that Agile works. Second, cracks appear at scale. Multiple Agile teams still struggle to align. Shared priorities become harder to maintain. Dependencies create delays. Leadership lacks a common mechanism for cross-team planning. Local agility no longer translates into enterprise success. Third, structured scaling emerges as a response. The organization begins looking for common planning cadences, shared roles, common language, dependency visibility, and stronger linkage between strategy and execution. That is where frameworks like SAFe enter the picture. SAFe, or the Scaled Agile Framework, was designed as a structured response to enterprise coordination problems. The goal is not to replace Agile team practices. The goal is to make Agile sustainable at scale. SAFe introduces shared planning rhythms so teams align around business outcomes rather than acting as disconnected delivery units. It creates common roles and language that help reduce ambiguity across product, business, and technology groups. It improves dependency visibility by creating more explicit planning structures. It also helps connect portfolio choices to team-level execution. That becomes particularly valuable in organizations trying to coordinate manufacturing, enterprise systems, data modernization, cloud platform work, and AI enablement at the same time. For example, a company might be scaling a common manufacturing data platform across multiple plants while also standing up AI use cases for predictive quality, integrating supply planning data, and standardizing digital workflows for quality management. Without a structured coordination model, each of those programs may move locally, but fail to create enterprise value coherently. With a stronger scaling model, those efforts can be planned, sequenced, and aligned in a more integrated way. This does not mean SAFe is the only option. It does mean the underlying problem is real. Once coordination becomes the dominant challenge, the organization needs a systemic response. That brings us to the key takeaways for today's session. First, team-level Agile has limits. It remains highly valuable, but it does not solve enterprise-scale coordination on its own. Second, scale changes the delivery problem. The challenge shifts from local execution to coordination across a larger system of teams, platforms, and leadership layers. Third, leadership layers add complexity. Funding, governance, strategy, architecture, and portfolio decisions all create friction that teams cannot resolve alone. Fourth, dependencies become a dominant force. In life sciences and manufacturing environments, those dependencies often span multiple delivery layers. Examples include systems, sites, vendors, cloud platforms, security, validation, and AI infrastructure. Fifth, systemic problems need systemic responses. Once coordination dominates the delivery system, organizations need a different operating model. That is where scaling frameworks such as SAFe become relevant. For life sciences organizations, this lesson is especially important. Modern digital transformation in the sector often includes manufacturing modernization, enterprise system integration, data platform enablement, cloud migration, AI use case deployment, and compliance-sensitive operating changes all happening at once. Agile at scale in that environment requires more than strong teams. It requires a coordination model that can align hundreds of contributors around common strategic outcomes. Organizational Agile scale is possible, but it requires more than sprint discipline. It requires system design. Thank you for joining this episode of the Agile Transformation Learning Series. As always, I'm Kenny Gibbons, and thanks for listening to our course on Agile Transformation. Hope you have a great day.